So, you've probably heard of proof of work and proof of stake, right? They're the two heavyweights, the giants that power huge networks like Bitcoin and Ethereum. But what if I told you there's a whole universe of other ways to agree on the truth? You see, the world of blockchain is like this massive, ongoing experiment. And today, we're going to dive deep into some of the most fascinating other consensus mechanisms out there, each one trying to solve that puzzle of digital trust in its own unique way.
But before we jump in, a quick hello. We're CodeAccessHub, and our whole mission is to take complicated tech topics and, well, make them simple. Today, we're tackling the incredible world of how blockchains actually reach an agreement. So, let's get right into it.
Here's the game plan for today. First, we'll talk about why we even need all these alternatives. Then, we'll take a tour through different families of consensus models. And we'll wrap it all up by looking at how projects pick the right one for them, and maybe even get a glimpse of what the future of agreement looks like.
All right, let's kick things off. Why are people even looking past the big two? Well, like pretty much everything in technology and engineering, it all boils down to one word: trade-offs.
This right here is the heart of the problem. Proof of work, which runs Bitcoin, is like a digital fortress. It's incredibly secure. But it's also pretty slow and, as we all know, uses a ton of energy. Then you have proof of stake. It's way more efficient for sure, but it can create this rich-get-richer problem, where the wealthiest players end up with most of the power. So the entire industry is on this quest for a kind of holy grail, something that's secure, lightning fast, and truly decentralized.
So let's ease into this by starting with an idea we're already familiar with. The next couple of mechanisms aren't about reinventing the wheel. Instead, they're really clever tweaks on proof of stake, designed to smooth out some of its rough edges.
First on our list is Delegated Proof of Stake, or DPoS for short. And honestly, the best way to think about it is like a representative democracy. Instead of every single person with staked coins getting a shot at making a new block, the token holders use their coins to vote for a small, select group of delegates who do all the hard work for them.
And this is where you see that classic trade-off, right? The huge benefit is that with only a small number of validators to sync up, like, say, 21 on a network like EOS, you can confirm transactions incredibly fast. It's super scalable. But you can probably spot the challenge. If that small group of delegates starts working together, well, you could end up with a pretty centralized system. It's that constant battle between raw speed and decentralization.
All right, next up we've got proof of importance, and this one directly tackles that rich-get-richer issue. The idea is simple. It's not just about how many coins you have, it's about what you do with them. POI looks at your stake, sure, but it also gives you an importance score based on your activity. Are you actually transacting and participating? It's all about rewarding the productive members of the community, not just the people sitting on a huge pile of coins.
Okay, so we've seen some clever twists on staking. Now, let's venture into some really creative territory. What if consensus wasn't based on computing power or staked money at all? What if it was based on completely different resources?
This is proof of capacity, where the valuable resource isn't your processor, it's your empty hard drive space. Think of it like this. Instead of buying lottery tickets one by one, you pre-calculate millions of them and store them on your disk. When it's time for the draw, you just quickly scan your drive to see if you have the winning number. The more disk space you have, the more tickets you can hold. It's a way greener approach to the lottery system that proof of work uses.
I know, this one sounds a little nuts, but it's all based on economics. With proof of burn, you show your commitment to the network by literally destroying your coins. You send them to an address where they can never be spent again. It's like a virtual sacrifice. By burning coins, you're making a long-term investment, proving you have serious skin in the game and believe in the network's future.
Now, proof of activity is a really smart hybrid model that tries to grab the best of both worlds. The process starts out like proof of work. Miners compete to find a new block. But here's the twist. Before that block is final, it has to be signed and validated by a random group of coin holders, which is the proof of stake part. So what's the point? Well, it's designed to solve a potential long-term problem for Bitcoin. What happens when all the coins are mined? This system keeps both miners and stakeholders paid to secure the network forever.
Okay, so from a hybrid, we go to a flexible model. Proof of weight isn't just one single protocol, it's more like a whole category of them. The core idea is that your influence, your weight in the system, is based on some useful factor that's specific to that network. So, for a network like Filecoin, which is all about decentralized storage, your weight is determined by how much data you're storing for other people. It's a perfect example of tailoring the consensus mechanism directly to the network's main purpose.
So far, we've mostly talked about these big, public blockchains that anyone can join. But what about private systems for businesses?
or even weirder architectures that don't even use a straight line of blocks. These setups need totally different ways to establish trust.
Enter proof of authority. In this model, you don't win the right to create a block with computing power or money. You win it with something much more old school, your reputation. The validators are known, pre-approved companies or individuals whose real-world identities are on the line. This is perfect for something like a corporate supply chain, where you need speed and you already know who the players are. The motivation, to be honest, is simple. Your entire reputation is at stake.
This one tackles a classic computer science puzzle. How do you get a group of generals to agree on a battle plan if some of them might be traitors? KBFT solves this with a super fast voting system. All the nodes gossip with each other constantly until a clear majority agrees. It's incredibly quick and gives you instant finality. But all that messaging means it really only works in smaller, permissioned networks where the generals are already known and trusted.
Proof of history. This is Solana's secret sauce for speed. Now, to be clear, it's not a consensus mechanism by itself. It's more like a supercharger for consensus. Think of it as a universal, unstoppable clock. It creates a verifiable timestamp for every single event, proving exactly what happened and in what order before the data even gets to the validators. This makes their job way easier and allows for absolutely insane transaction speeds.
And now for something completely different. Directed Acyclic Graphs, or DAGs, basically throw the whole idea of a single chain of blocks out the window. In a DAG, every new transaction has to confirm a couple of previous ones, creating this intricate web-like structure. The cool part is this allows the network to process transactions in parallel, instead of one by one. The result? Often feeless, super fast transactions, which is perfect for things like the Internet of Things or sending tiny micropayments.
Okay, wow, we have just sprinted through a ton of different ideas. I know, it's a lot to take in. So the billion-dollar question is, how on earth does a project choose the right one? Well, it really all comes down to picking the right tool for the right job.
This table really just lays out the core dilemma perfectly. Every single one of these choices is a compromise. If your number one goal is maximum unstoppable security for something like digital gold, proof of work is still the king. But you're going to pay for that in speed and energy. Need crazy fast transactions for your enterprise app? Proof of authority is your answer. But you're giving up on true decentralization. There is really no such thing as a free lunch.
And here's how you see those trade-offs play out in the real world. For Bitcoin, the goal is to be the most secure financial asset in history, so the speed and energy cost of proof of work is a price worth paying. For a project like VeChain, which tracks luxury goods, they need efficiency and trusted validators, so proof of authority is the obvious pick. And for platforms trying to build the next Facebook on the blockchain, they need the raw transaction throughput that something like DPoS or a DAG can provide. The mission always defines the mechanism.
So this all leaves us with a huge and I think really fascinating question for the future. Are we watching a sort of battle royale where one of these consensus models will eventually emerge as the one true winner? Or are we actually heading towards a future that looks more like a multiverse, a vibrant, interconnected ecosystem of thousands of specialized blockchains, each with its own perfectly tailored way of agreeing on reality?
Hey, if you enjoyed this little trip through the consensus multiverse, there's plenty more where that came from over on the CodeAccessHub YouTube channel. Make sure you like this explainer, subscribe for more deep dives, and definitely hit that notification bell so you don't miss the next one. Thanks so much for watching.